The first thing you do with all this motion, the movement we have in a circular in the displacement of the follower. So from 0 to 180 degree is rise, is lifting, and from 180 to 240 is dwelling, and from 240 to 360 is what is falling. So what I'll simply do is I'll take my instrument and I am going to draw my horizontal line this way. Remember, we're drawing for uniform velocity, right? So the next thing is I'll take this also and I'm going to project here up. Can you see that? Now after I've done that, depend on your skill, you can say let 15 degree represent 1 centimeter, or you can also say let 1 centimeter represent 30 degree. So if I'm taking 1 centimeter to represent 30 degree, means that I'm moving 12 centimeter making 360 degree. Remember, it is 360 going in one complete revolution. So from 0 to 12 is 360, right? So what I'll simply do is I can even make it bigger than this if I want to. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the first one is 0 degree. This is 0 degree. This is 30 degree. This is 60. This is 90. This is 120. This is 150. This is 180. This is 210. This is 240. This is 270. This is 300. This is 330. And this is what 360 degree. What we're about to do, we'll call it the profile diagram, right? This is a profile diagram we're about to do. Now after that, the next thing I'll do is what will now be the height? The height is always the lift or the rise. That will be the height of this profile diagram here. So and we're giving it to be 30. So I'm going to measure 30 from 0 to what? To 30. Can you see that? And I'm going to take here up this way, and I'm going to close here too this way. Then the rest will be going up. So this is 30, each of them is 30 degree apart. So this is the profile diagram. That is the profile diagram here. Hope you can see that. Now the next thing is the question says it rises or it lifts from 0 to 180. So since we are dealing with uniform velocity, so for me here the word uniform velocity, it will just be a straight line. So it moves from 0 to 180, and this is the highest point. This is how it rises to 30. So it moves from 0 to 30 to 180 with a lift of what? 30 millimeter, right? So from here to here is 30, and this is 180 to this point. So I'll just take my instrument and then I'll just draw a straight line this way. Can you see that? Then from 180 to 240 it dwells or it rests. So I'll just close it up. Alright. Then from 240 down to 360 it falls, still the same distance. of 30 millimeter. So I'll just take this and I'll close it up. So this is our profile diagram for a cam or a follower that lifts 30 millimeter with uniform velocity from 0 to 180 and dwells from 180 to 240, then fall with uniform velocity again with what? 30 millimeter. This is what we have for the first one. This is uniform velocity here. So anytime you are dealing with uniform velocity, you use a straight line. So I can easily write it here by saying this is the part, the outstroke, or we say where it falls, or we say the outstroke. So this is the dwell, or we say rest, right? And this is lift, or we say rise. Two, or we say the instroke, outstroke. So the next one is uniform simple harmonic motion, right? So what we have from our question here, the simple harmonic motion here, it says the same thing happened for simple harmonic motion. So what I'll do the same thing here. I'll just draw this way, and I'm going to take this up, right? Then since it is 30 for simple harmonic motion, there's something you need to understand, that the graph is a sine curve, right? So we'll always use a semicircle when dealing with what? Simple harmonic motion. So there will be a semicircle at both at the beginning and the ending. So what I'll do is I'll do the same thing here from 0, since I'm using 1 centimeter to represent 30 degree, and the same measurement, which is what the lift is 30 millimeter. So I'll just take half of the 30. Look at what I'm about to do, which is 15, from 0 to 15. This is what we have, and I'll place it here. I'll mark, then I'll come here, and I'm going to place it this way. Then I'll draw my semicircle. I'll come here also, I'll do the same thing. I'll draw my semicircle. Hope you can see that. Now the next thing is I'm going to close it up this way. From here to this point. And I'll draw my line for the first one. It says 0 to 180 is what? Is lift with the height is what? 30 millimeter. Don't forget that. Then I'm going to, from that 180, I'll take it up. Hope you can see that. Then if you count 0, 1, 2, 3, 4, 5, 6, meaning that you're going to divide this circle into 6. Is that taken? So I can easily use this way. I'll mark up. I'll come here also. I'll mark here too. Then this other one here, I've not drawn that. The middle one, just a straight line. Then from that middle part, I'll place it there and I'll mark here and here. Alright, then take my rule, then I'll use this to join the center point here. So before I proceed, if you want to watch a video that involves uniform velocity, right? I will drop the link at the description box. So let's proceed. Now, I will now take each of those points. I will now draw it this way. This will come here, right? This will come here, right? This is coming from here to here, and this is coming here to faint line. So if this is 0 degrees, 0 means 0. The next one is what? 30 degree. The 30 is going to meet 30 here. The next one is 60 degree. 60 degree will come here and meet what? 60. We have the next one, which is what? 90 degree. 90 degree is coming from here to meet, I'll just take it here, to meet 90. The next one is 120 degree. So the 120 is coming to meet 120 here, right? And the next one is what? 150 degree. The 150 is coming to meet 150 here. And the last one on the list is 180 degree, and it's coming here to meet 180 at this point. So I'm going to use my French curve, and I'm going to connect this curve. So you need to understand, in simple harmonic motion, it is always a curve. It's a sine curve. So this way, and this way too. And this way. Here also. Taking 3 at a time. So this is what we have. Then we move again. It says from 0 to 240 is dual, just like here also. That means from 0, this is up to where 240 is. So it means I am going to thicken from here to here. Can you see that? Now the remaining one is, this is 0, this is 1, 2, 3, 4. It's the remaining 4 different points to get to what? 360. So meaning that I'm going to divide here into 4. You get the logic? From 0, we have 1, 2, 3, 4, 5, 6. I divided it into 6. We have 0, we have 1, 2, 3, 4. I divided into 4. Remember, it's only your simple harmonic motion. Either you divide the semicircle into 6 or into 4. Get that straight. Now, when I place my instrument this way, I can easily divide my 45 degrees set square. I'll divide this into 4. Can you see that? So that will be using 45. So if I do that, this will be 0, 45. This will be what? 90. This will be what? Another 135. Then we have what? 180. Right? Each of them is 45 degree. Is that okay now? So it's falling. So if I should come here now, I will now project all this to touch here, and all this to touch here. Is that again? So if I'm doing that, this is what we have, 240 at this point. Yeah, this is 240 here, 180 and so on. So we're starting from what? From 240. This one is what? 270. We have the next one, which is what? 270 plus that will have 300. We have 330. Then what? 360. So when I project this up, this is coming up, this is coming up, and this is coming up. So if you move, 270 is meeting 270 at this point, 300 is meeting 300 at this point, 330 is meeting 330 at this point, then 360 is here. So I'm going to connect this also in this manner. In this manner here. And in this manner also. So this is what we have. So here it rises with simple harmonic motion and it falls with simple harmonic motion. This is also the dual here. Dual, fall, and lift, or you say rise, like I said earlier. So this is the profile diagram of the follower, right? When it's using simple harmonic motion, and this is uniform velocity. So we'll go to the last but not the least, which is uniform acceleration. So with that, I'll just push this up a little bit. So let's see what we can have here. Are we together? So when we do that, now I'll do the same thing. I'll draw it out, the same procedure, and I'll take it up also, right? And I'll do the same thing I did in the previous one. This is for uniform acceleration and retardation. So it rises with uniform acceleration and it falls with uniform deceleration or retardation. So but the height still remains to be what? 30. So I'm going to take that 30 from 0 to 3 is 30. So what we have here. And I'm coming here. Is that taken? So what you do here when you're dealing with uniform acceleration and retardation is this. The curve for this is always parabolic, right? So if you look at the question carefully, it says from 0 to 150 is lift, and 150 to 210 is dwell, then 240 to 360 is fall. So the first one is 0 to 150. So this is from 0 to 150. I'll just come here and I'll close it up. Can you see that? So I'm going to divide here in whatever I divide the vertical, I must always divide the horizontal, right? So what I'll do is, then that's the first stage, the lift. Then the next one is 0 to 150 to 210. So this is 150 to 210. That is dwell. This is another stage. Then the remaining one is what? Is fall. So what I will do is I will draw my inclined line from here to touch here, faint line. From here also, remember it is faint line. From here also I'll draw the line that will touch from here to here. Can you see that? So the most important thing is I'm going to divide this into 5. Right? I'll divide it into how many? Into 5. Into 6. So if this is 30, if we divide 30 by 5, that will be what? 6. So I'll place it this way. So from 0, this is 5, 10, 15, 20, 25, and what? 30. So if this is the midpoint here, this is the midpoint here. That is where I am going to draw my vertical line. All good? 0, 1, 2, 3, 4, 5, 6. So I divide it into 6 because here is into what? Into 6 also. 0, this is 0, 1, 2, 3, 4, 5 also. So just divide it that way. Now I'll now divide this also to see what I'm going to do. This point I have here is here, and I have this point here too here. I'm transferring this point to this point. Here also to this point. Here also to this point. Can Can you see that? Then I'm going to project each of this from this point here. I'll project this to touch here. From this point here, I'll project it to touch here. Can you see that? Also from here too, project it to touch here. And from here, I'll project it to touch here. Faint line. Is that taken? So what I'll do is I'll take the 60° I have from here to touch this, and this one from here to touch this. That means the first angle to the first line, second one to the second one, and the third one to the third one. So all these points you see are my parabolic curve that we have here, which is coming like this. So we're still coming. Then the next one from here, the first point, this is the second point here, so I'll move from the top to the second line. Then the third point to the second line. This one will stop here. The first point, first line, second point, second line, and the third point, they'll all meet here. So I'll take my French curve and I'm going to join this together. Then this is coming to touch here this way. So this is what we have. When you hear uniform acceleration, this is what you're going to have. I will do it here also. Is that taken? So what I'll simply do is this. The same thing happens. All these points you see, let's see, this is 0, this is 30, and so on. Let's see, this is what we have. Then this point, I'll transfer it from here to cut here. I just need the midpoint. This is the midpoint here. Right? So the midpoint is coming all through here like this. So from that midpoint, I'll draw this up this way. So transfer those points. All these points you see here. This, and this. I'm also transferring the points just to reduce my stress. So from this end, I'll take this to touch here and here. Then from this end, I'll take this to touch here and also here. So the truth of the matter is you can even divide it into 8, but ensure it should always be an this is 0, 1, 2, 3, 4, 5, 6. It should always be an even number. 8, 10, 12, and so on and so forth. So I just use 6 here. So what I'll do next is just like we did earlier, from this end point, I'll go to the first line, take it to the first line, to the second line, take it to the second line, then the third one is here. So I need this point, and this point. Then I'll come from here also. This is the first line here. This is the first line. This is the second line. Then what? The third line. So this is what I need here. So I'll use my French curve and I'm going to join it this way. And this way too. Hope you can see that. Then the dual here. So this is what we have. So from here to here, it lifts. Then from here to here, it dwells. Then from here to here, it falls. That's what I mean here. So this is the motions that we have. So let me show you all together. So these are the motions that we have here. All together. So the uniform velocity, rise, dwell, and this is fall. So it's rise uniform velocity and fall uniform velocity. This it rises with harmonic motion and falls with harmonic motion. This it rises with uniform acceleration and fall with uniform deceleration or retardation. These are taken now. So if you want to see videos on this, just check in the description box, or you can look at the end of the video. You see a playlist of different questions involving all these questions here. So if you found this helpful, don't forget to like, subscribe, and also share the video. Thanks for watching.